auditors. Are you ready to learn more about the key elements of the database environment? Continue watching this video for the discussion of Ms. Rizalyn Mariari, Ms. Giselle Daguro, Ms. Rica Alipio, Ms. Erica May Gatbunton, Ms. Danica May Manyalak, Ms. Dina Ricolin K. Paharin, and yours truly. Without any further ado, let's now dive into this informational discussion.
Okay? My topic for today is all about database management system. First, what are data and database? Data is a collection of a distinct unit of information. This data is used in a variety of forms of text, numbers, media, and many more. Examples: name, age, weight, height, etc. Now let's move on to the next word and understand what is database. It is an organized collection of structured data to make it easily accessible, manageable, and update. In simple words, you can say a database is a place where the data is stored. The best analogy is the library. The library contains a huge collection of books of different types. Here, the library is the database and books are the data. So now, let's define our main topic for today, which is the database management system. DBMS provides a controlled environment to assist or to prevent access to the database and to efficiently manage the data resources. As you can see in the figure 4.3, elements of the database concept. Users forwarded the transaction to the application or user program. These applications users accesses an existing application program to perform daily tasks. And also users have system requests to the system development process and also database administrator. DBMS received instruction from a database administrator DBA and accordingly instruct the system to make the corresponding changes. These commands are used to load, retrieve, or modify existing data from the system. A DBMS provides the language called Data Definition Language (DDL) for defining the database objects on the three levels. It also provides a language for manipulating the data called the Data Manipulation Language (DML), which make it possible to access records, change values of attributes, and delete or insert records. Last is the query language. This considered the standard user and application program interface for a relational database. Example of this are FileMaker Pro and Microsoft Access. The last two in the concept are the host operating system and physical database. A DBMS enables us to define a database on three levels. First is physical. It looks at how data is physically arranged, stored, and accessed on the magnetic disk and other secondary storage devices of a computer system. Schema is an overall logical view of the relationship between data in a database. Last is the subschema. Is a logical view of data relationship needed to support specific end-user application programs that will access the database. So now let's move on to the DBMS, some typical features that includes 4. First is the program development. The DBMS contains application development software. Both programmers and end users may employ this feature to create application to access the database. Second is the backup and recovery. During processing, the DBMS periodically makes backup copies of the physical database. In the event of disaster like disk failure, program error, or malicious act that renders the database unusable, the DBMS can recover to an earlier version that is known to be correct. The third one is the database usage reporting. This feature captures statistics on what data are being used, when they are used, and who uses them. Last one is the database access. This is the most important feature of DBMS, is to permit authorized users access, both formal and informal, to the database.
Users. There are two ways or methods on how the users can access the database. First is through the formal access application interfaces. In formal application interfaces, the user programs prepared by the system's professionals send data access requests or calls to the database management system, which validates the request and retrieves the data for processing. Under this mode of access, the presence of the database management system is transparent to the users. In both batch and real-time, the data processing procedures for transactions such as sales, cash receipts, and purchases are essentially the same as they would be in the flat file environment. When we say flat file environment, it has a database store that contains records following a uniform format. In short, the file is simple. Under the formal application interfaces, we have the DML, or the Data Manipulation Language. It is defined as the proprietary programming language that a particular database management system uses to retrieve, process, and store data. Inserting DML commands enables standard programs, which were originally written for the flat file environment, to be easily converted to work in a database environment. The use of standard language programs also provides the organization with a degree of independence from the database management system vendor. If the organization decides to switch vendors to one that uses a different DML, it will not need to rewrite all the user programs. By replacing the old DML commands with the new commands, the user programs can be modified to function in the new environment. Next is we have the DBMS operation, or the Database Management System operation, which was previously illustrated in the figure 4.3. Now, let's see the following description of the typical sequence of events that occur while accessing data in the database management system. First, a user program sends a request for data to the database management system. The requests were written in a special data manipulation language that is embedded in the user program. Second is that the database management system analyzes the request by matching the called data elements against the user view and the conceptual view. Note that if the data request matches, then it is authorized and processing proceeds to step 3. But if it does not match the views, then the access is denied. Third, the database management system determines the data structure parameters from the internal view and passes them to the operating system, which performs the actual data retrieval. The said data structure parameters describe the organization and access method for retrieving the requested data. Fourth, using the appropriate access method, the operating system interacts with the disk storage device to retrieve the data from the physical database. The appropriate access method refers to an operating system utility program. Fifth, the operating system then stores the data in a main memory buffer area managed by the database management system. Sixth, the database management system transfers the data to the user's work location in main memory. At this point, the user's program is free to access and manipulate the data. And lastly, when the processing is complete, steps 4, 5, and 6 are reversed to restore the processed data to the database. The second method on how the users can access the database is through the informal access query language. Query is defined as an ad hoc access methodology for extracting the information from the database. Through the informal method of queries, the users can access data via direct query, which requires no formal user programs using the database management system's built-in query facility. This feature allows authorized users to process data independent of professional programmers by providing a friendly environment for integrating and retrieving data to produce ad hoc management reports. This query capability of the database management system permits end users and professional programmers to access data in the database directly without the need for conventional programs. The SQL, which is often pronounced as SQL, or known as the Structured Query Language by the International Business Machines Corporation, a leading American computer manufacturer, has emerged as the standard query language for both mainframe and microcomputer database management systems. It is a fourth-generation non-procedural language, such as the English-like commands, with many commands that allow users to input, retrieve, and modify data easily. Then we have the select command, which is known to be a powerful tool for retrieving data. Let us see the figure 4.5, an inventory database, as it illustrates the use of the select command to produce a user report. Here, the users select the data visually by pointing and clicking at the desired attributes, and this visual user interface then generates the necessary SQL commands automatically in order to produce the desired report from the database. As we can see, the SQL is an efficient data processing tool. It places ad hoc reporting and data processing capability in the hands of the end user or manager. However, the query feature is an important control issue, so the management must ensure that it will not be used to achieve unauthorized access to the database.
Next topic is the database administrator. The database administrator is responsible for managing the database resource. The sharing of a common database by multiple users requires organization, coordination, rules, and guidelines to protect the integrity of the database. In large organizations, the database administrator function may consist of an entire department of technical personnel under the database administrator, while in smaller organizations, the database administrator responsibility may be assumed by someone within the computer services group. Next is the organizational interactions of the database administrator. As you can see in the figure, it shows some of the organizational interfaces of the database administrator. Of particular importance is the relationship among the database administrator, the end users, and the systems professionals of the organization. Let's refer again to figure 4.3 as we examine this relationship. When information systems needs arise, users send formal requests for computer applications to the system professionals of the organization. The requests are handled through formal systems development procedures. If they have merit, they result in programmed applications. Figure 4.3 shows this relationship as the line from the user block to the system development block. The user requests also go to the database administrator, who evaluates this to determine the user's database needs. Once this is established, the database administrator grants the user's access authority by programming the user's view. We see this relationship as the line between the users and the database administrator, and between the database administrator and the data definition language module in the DBMS. By keeping database access authority separate from system development, the organization is better able to control and protect the database. Intentional and unintentional attempts at unauthorized access are more likely to be discovered when the activities of these two groups are segregated. Next, the duties of the database administrator, which fall into the following areas: database planning, database design, database implementation, operation and maintenance, and database growth and change. The table here presents a breakdown of specific tasks within these broad areas. First, under database planning, specific tasks includes develop organization's database strategy, define database environment, define data requirements, and develop data dictionary. Under database design, include logical database, external users view, internal view of databases, and database controls. Under implementation, include determine access policy, implement security controls, specify test procedures, and establish programming standards. And under operation and maintenance, specific tasks include evaluate database performance, reorganize database as user needs demand, and review standards and procedures. And under the database change and growth, include plan for change and growth and evaluate new technology. Another important function of the database administrator is the creation and maintenance of the data dictionary. The data dictionary describes every data element in the database. This enables all users and programmers to share a common view of the data resource, thus greatly facilitating the analysis of user needs. The dictionary may be in both paper form and online. Most DBMS employ special software of managing the data dictionary.
I am Erica Maygat Punton, and I am going to discuss the fourth major element of the database approach, which is the physical database. So this is the lowest level of the database and the only level that exists in physical form. The physical database consists of magnetic spots on metallic coated disks. The other levels of the database are abstract representations of the physical level. This is the list of file processing operations that data structures must support. Number 1, retrieve a record from the file based on its primary key value. Second, insert a record into a file, then update a record in the file. Fourth, read a complete file of records. Fifth, find the next record in a file. Then sixth, scan a file for records with common secondary keys. Then lastly, delete a record from a file. A data structure is a specialized format for organizing, processing, retrieving, and storing data. There are several basic and advanced types of data structures, all designed to arrange data to suit a specific purpose. Data structures make it easy for users to access and work with the data they need in appropriate ways. Most importantly, data structures frame the organization of information so that machines and humans can better understand it. Data structures have two fundamental components: the organization and access method. Data files are organized so as to facilitate access to records and to ensure their efficient storage. A trade-off between these two requirements generally exists. If rapid access is required, more storage is required to make it possible. The records in sequential files are stored in contiguous locations that occupy a specified area of disk space. Records in random files are stored without regard for their physical relationship to other records of the same file. Random files may have records distributed throughout a disk. When a file is used, information is read and accessed into computer memory, and there are several ways to access this information of the file. Some systems provide only one access method for files. Other systems, such as those of IBM, support many access methods, and choosing the right one for a particular application is a major design problem. There are three ways to access a file into a computer system: sequential access, direct access, and index sequential method. In sequential access, it is the simplest access method. Information in the file is processed in order, one record after the other. This mode of access is by far the most common. For example, editor and compiler usually access the file in this fashion. While in direct access, another method is direct access method, also known as relative access method, a file-length logical record that allows the program to read and write record rapidly, in no particular order. The direct access is based on the disk model of a file, since disk allows random access to any file block. For direct access, the file is viewed as a numbered sequence of block or record. Thus, we may read block 14, then block 59, and then we can write block 17. there is no restriction on the order of reading and writing for a direct access file. A block number provided by the user to the operating system is normally a relative block number. The first relative block of the file is 0, and then 1, and so on. While index sequential method, it is the other method of accessing a file which is built on the top of the sequential access method. These methods construct an index for the file. The index, like an index in the back of a book, contains the pointer to the various blocks. To find a record in the file, we first search the index, and then, by the help of pointer, we access the file directly. Lastly, the criteria that influence the selection of the data structure includes rapid file access and data retrieval, efficient use of disk storage space, high throughput for transaction processing, protection from data loss, ease of recovery from system failure, and accommodation of file growth.
DBMS model or Database Management System model is an abstract representation of the data about the entities. This includes the resources or the assets of the organization, the events or the transaction, and the agents or the personnel or customers. The purpose of data model is to represent entity attributes in a way that's understandable to the users. It should be noted that each DBMS model is based on a particular conceptual model. There are three common models, which are the hierarchical, network, and the relational model. Hierarchical and network models are also called the navigation models because of their common conceptual similarities, which are explicit links or paths among their data elements, while the relational model is based on the implicit linkage between its data. Now here are some database terminologies that we should review before continuing to the models. First is the data attribute or the field. It's a single item of data such as the customer's name, address, or account balances. Entity is a database representation of the individual resource, event, or agent about which we choose to collect data. There are two types of entity. First is the physical entity, which includes the inventories, customers, and employees. And the second is the conceptual entity, which are the sales, depreciation, expense, and accounts receivables. Record type is a grouping together of data attributes that logically define an entity. For example, in the event of the purchase would form a purchase order record type, and multiple occurrence of this purchase order record type are physically stored in the purchase order table or file, which are part of the company's database. Database is a set of record types that an organization needs to support its business process. Association is a record types that constitute a database, exists in relation to other record types. There are three basic associations: one-to-one association, one-to-many association, and many-to-many association. Now take a look at figure 4.7. On the upper left part of the figure is the one-to-one association, which shows that in every occurrence of record type X, there is only one or possibly zero occurrence of record type Y. For example, for every employee in the employee record, there is only 1 or 0 for new employees occurrence of year-to-date earnings table. On the upper left side of the figure is the one-to-many association. For every occurrence of record type X, there is 0, 1, or many occurrence of record type Y. For example, for every customer in the customer table, there is 1 or 0 or many sales orders in the sales order record, which means that customers may purchase none or one or many purchase from entity. Now at the bottom part of the figure is the many-to-many associations, illustrated here that in every occurrence of record type X and Y, there are 1 or 0 or many occurrences of type Y and X. For example, the supplier may provide to the company 0, 1, or many inventory items. Similarly, the company may buy 0, 1, or many inventory items to the suppliers. Now let's move to the hierarchical model. Hierarchical model is the earliest database management system. It's popular method of representation because it reflects more or less faithfully many aspects of an organization that's hierarchical in the relationship. It organizes data in a tree-like structure, and an important factor about this is that each child node will have a single parent only. Illustrated in the figure 4.8 is a portion of the hierarchical model about the relationship between two linked files. Each set contains one parent node and one child node. Notice in the level of file B is both child of the file A and the parent of files X, Y, and Z. Note that files at the same level with the same parent are called siblings. Thus, files B and C are considered siblings. The higher segment is the root segment and the lower segment is the leaf. Hierarchical model is also called the navigational databases because traversing the files requires following a predetermined path established through explicit linkage or pointers between related records. In figure 4.9, to have access to the invoice line item files, the DBMS should have access first to the customer file, which is the root. Then the record contains a pointer towards the sales invoice line, and the sales invoice file also contains a pointer towards the invoice line item file. The figure 4.10 is just a more detailed file structure for the partial databases in figure 4.9. Now let's move on to the limitations under the hierarchical models. The first limitation is the parents may have one or more child records, just like in figure 4.9, in which aside from the sales invoice file, there is also a cash receipts file under the customer's file. As illustrated in the figure 4.11a, we can assume that the sales invoice file is child of both natural parent salesperson's file and customer's file. With that, the management will wish to integrate the sales activity with the customer service and the employee's evaluation. But even though it's logical, it will violate the rule of the hierarchical model. Since complex relationships cannot be depicted, integration is restricted. The second limitation is that no child record can have more than one parent, which often restricts and limits the usefulness of hierarchical constraints. In figure 4.11b is the most common way solution to improve the first restriction, which is to duplicate the sales invoice files, which will create two separate hierarchical models. Unfortunately, achieving this improved functionality would also mean an increase in data redundancy. This is why network model will be discussed next to answer this problem efficiently.
Let us now proceed to the third model under DBMS, which is the network model. In the late 1970s, the American National Standards Institute Committee created the Committee on Development of Applied Symbolic Languages, or also called as CODASIL, which formed a database task group to develop standards for database design. CODASIL developed the network model for databases. The most popular example of the network model is the IDMS, which means Integrated Database Management System, which was first marketed at B.F. Goodrich and later marketed by Cullinan Database Systems, or renamed as Cullinan in 1983. The distinction of the network model from the hierarchical model is that it permits a child record to have multiple parents. For example, let us refer to the figure 4.12. Invoice number 1 is the child of salesperson number 1 and customer number 5. Pointer fields in both parent records explicitly define the path to the invoice record. This invoice record has two links to related records. The first is a salesperson linked to invoice number 2. This record resulted from a sale by salesperson number 1 to customer number 6. The second pointer is the customer linked to invoice 3. This represents the second sale to customer number 5, which was processed this time by salesperson number 2. Under this data structure, the management can track and report sales information pertaining to customers and sales staff. Now let us tackle the advantages of the network model. First is the conceptual simplicity. Just like the hierarchical model, the network model is also conceptually simple and easy to design. Next one is the data integrity. The network model does not allow a member to exist without an owner, so it ensures data integrity. And the last one is data independence. The network model is better than the hierarchical model
in isolating the programs from the complex physical storage details. Let's move on to the disadvantages of the network model. So first is system complexity. All the records are maintained using pointers, and hence the whole database structure becomes very complex. The second one is the operational anomalies. The insertion, deletion, and updating operations of any record require large number of pointer adjustments. And the last disadvantage of network model is the absence of structural independence. Structural changes to the databases is very difficult.
Now we're going to talk about the last topic under DBMS models, which is the relational model. The relational model was originally proposed by Edgar F. Codd in the late 1960s. It is an abstract model that organizes data within a database. The main difference between the relational model and navigation models is how data association is presented to the users. The relational model portrays data in the form of two-dimensional tables. The most fundamental elements of relational models are: number 1, relations, which is the tables; number 2, tuples or the rows in the table; and number 3, each tuple sharing a set of attributes or columns. Observe figure 4.13. Across the top of the table are the attributes such as the customer number, name, address, and account balances. In more simpler definition, attributes are the title of each column. Tuples, on the other hand, are the records under each of the attributes. For example, look at the second row of the table. It is the tuples that mean that customer number 1875 is under the name J. Smith with an address of 18 Elm Street and account balance of 1,820. A tuple is a normalized array of data that is similar but not precisely equivalent to a record in a flat file system. A properly designed table consists of 4 characteristics, which are: first, all occurrences at the intersection of a row and a column are a single value, meaning that no multiple values or repeating groups are allowed. Second, the attribute value in any column must all be of the same class. Third, each column in a given table must be uniquely named. However, different tables may contain columns with the same name. Fourth, each row in the table must be unique in at least one attribute. This attribute is the primary key. Note that each relation or table should be named differently from the other tables. Note also that each attribute in the row should be dependent on the primary key and independent from the other attributes. Relations are formed by an attribute that is common to both tables in the relation. Now look at figure 4.14. The record type is the same as in figure 4.10, but the difference is that the latter has explicit pointers to show the relationship of the data, while in the former, the linkage is implicit. Focus on the customer table in which the customer number is the primary key of the table that is embedded with the sales invoice and cash receipts tables. Similarly, the invoice number under the sales invoice table is the primary key of the table that is embedded in the line item. If you notice, under the line item table, there are 2 numbers in each row, which are the invoice number and the item number, but only the invoice number has the logical link to the sales invoice table. For example, in the same figure, the users want to view the invoices of customers number 1875. The system would search for a sales invoice table with the primary key, or also known as the foreign key value, which is 1875. We can see that there is only one invoice under customer number 1875, which is the invoice number 1921. To obtain line item details for this invoice, a search is made to the line item table for records with a foreign key value of 1921. 2 records then are retrieved. The degree of association between the tables determines the table used for assigning foreign keys. If the association is one-to-one, either of the table's primary key may be embedded in the other as a foreign key. In one-to-many associations, the primary key on the one side is embedded in as a foreign key on the many sides. For example, the customer may have many invoices and cash receipts record in the sales invoice and cash receipts tables, respectively. The many-to-many association between tables does not use embedded foreign keys. Instead, a separate linked table containing keys for the related table needs to be created. That would be all for tonight's discussion about the key elements of the database environment. We hope that you have learned a thing or two. Thank you